Okay, me again. All right, I'm going to try an online lesson for physics students, and this is on the topic of statics. All right, so put this in your notes under statics. Okay, so that's what we have. All right, now what statics is, statics is, static problems are for things that you don't want to move. So what don't you want to move? Well, let's say you're building a building, like a skyscraper or something like that. Obviously, you don't want the thing to move. Let's say that you're an engineer and you're designing a bridge. Most people don't want bridges to move. So what you want to do is you analyze the situation in such a way so you get all the forces in the situation to cancel out. And here's what I mean by that. So let me just kind of teach by example, and I'll show you a typical example of a statics problem. So let's say I have a weight and it's hanging, okay, from, this is like a ceiling or something like that, and I have a rope like this, and this is at some angle, and I'll call this theta 1. And then I have another rope over here, and this is at a different angle, theta 2. And then let's say I have a weight or mass hanging from it like that. Okay, so the thing's just hanging there. So I'm going to call this, the force in this rope, I'm going to call it tension number 1. So I'm going to call it T1. And then I'm going to call this T2. Okay, and so what I want to do is I want to find out, let's say I know the mass, that's known. And what I want to do is I want to find what is T1 and what is T2. Now, if you notice, I have two unknowns. So let's say we know the mass, and I'm not throwing any numbers in right now. You guys can throw in numbers with a calculator or something like that, all right? And actually, let me move this just a little bit closer, probably. So you can see it a little bit better, maybe, hopefully. All right, and anywho, so what you got going on here is you have two unknowns. And if you have two unknowns, some math teacher at some point taught you need two equations to solve two unknowns. So where do you get these equations? Well, you get them from the second law, which is, and you're probably saying, well, okay, that's the second law, but that's only one equation. So where do you get two? Well, the second law, we have to take into account two directions here, an x and a y. So we're going to apply the second law in two directions, and I'll show you how to do that. It's actually not hard, it's pretty easy. Now, the nice thing about a static problem is this side of the equation, if the thing is not moving, your acceleration is 0, so this whole side of the equation just goes away and becomes 0. Let me get my eraser. So I have to seriously conserve board space while I'm doing this. So the sum of the forces is 0. But actually, let's go a little bit further. We will say that the sum of the forces in the x direction is 0, and the sum of the forces in the y direction is 0 also. And we'll get one equation from here and one equation from there. Tracking with me on that? Okay, so that being the case, let's do this. And what I'm going to do is, first thing I'm going to do, now you guys are going to have to bear with me here because I've got to conserve board space, so I'll do a lot of erasing, but the concept is obviously that since it's a video, you guys can just kind of scroll back and take any notes that you need to and just kind of have one continuous sheet of notes on this and so on, right? So that being the case, here we go. So first thing you do is you do a free body diagram. So to save space, I'm just going to draw a dot as this mass. And what are my forces on it? Well, I have the weight going down, so I'm going to draw that. And that's going to be mg. And then I have these two tensions, but wait a second, they're at angles. So what you do is you break up the tensions into their components. So I have one component going here for T2, and then one component going up. And same thing with T1, I have one component going this way, pulling that way, and then another part going up. As Grandma Golis would say, like so. All right, so let's continue with the free body diagram. And I actually am going to make it a little bit bigger. I'm just going to do this here. Okay. All right, so I'm going to have the weight, mg going down like that. And then what I'm going to have now, if you do, now whatever these angles are, you see how they're at an angle with the ceiling, whatever this angle is here, this is going to be the exact same angle. How do you know? Again, some math teacher taught you like alternate interior angles and so on. So this component right here, this is going to be T2 cosine of theta 2, and that's going to be going to the right. So I'm going to have T2 cosine theta 2, and that's going to the right. And then I'm going to have T1 cosine theta 1 going in that direction, balancing it out. So T1 cosine theta 1. Okay, now going up. Now be careful because I have two forces and they're in the same direction. And you just kind of draw them side by side on your free body diagram. So I'm going to go off to the side a little bit. I'm going to have T2 sine theta 2, and that's going up. And then T1 is going to add to that. So I'm going to draw that a little bit over here. And that's going to be T1 sine theta 1 going up like that. Okay? Now I'm just going to redraw it. I'm going to erase this and I'm going to show you the equations underneath it. So here I go. All right, so let me get rid of this because this is all getting kind of busy up here. So watch. Okay. Actually, I think I'm just going to leave that there and I'll do the equations on top of it. So all right, so here's my T1 sine theta 1, T2 sine theta 2. Going up like that, and now what I'm going to do is I'm going to sum up the forces in the x direction. Watch how I do that. That's pretty simple. And just remember your sign convention. So right is positive, left is negative. So I'm going to write T2 cosine theta 2 minus T1 cosine theta 1, and that's equal to 0. How do I know it's equal to 0? Because it's equal to MA, and A is 0, so the whole thing is 0. Which basically says that T2 cosine theta 2 is equal to T1 cosine theta 1. Okay. In the y direction, when I sum up the forces in the y direction, I get this, right? I have T2 and T1 going up, and then I have mg going down, so it's T2 sine theta 2 plus T1 sine theta 1 going up minus mg, and that's equal to 0. Okay. So, let's also assume, I should have said this. Let's also assume in this case that I know what the angles are. All right. So, here we go. So let's say, so I know m, I know theta 1, and I know theta 2, and I'm looking for T1, and I'm looking for T2. I don't know why I put a 0 there, and I can't draw a question mark for real. There. Okay, so I don't know those. All right, so now I have my two equations. I have T1, T2, and up here, the cosine terms up here, and I have the sine terms down here. So now what you do in order to solve them is you just kind of go through the algebra that your teacher taught you. So what I'm going to do is I'm going to take the first equation, it's probably the easiest thing to do, and I'm going to solve for one of the t's. Okay, so it's a little bit hairy, not hard, but it's a little bit hairy. All right, and but it's certainly doable. So what I'm going to do is I'm going to take this equation right here, and I'm going to rearrange it, and that's going to be t2 cosine theta 2 equals t1 cosine theta 1. And then what I'm going to do is, how about I solve for I'll solve for t2, all right, in terms of t1. All right, so what I'm going to do is I'm going to divide by the cosine term. It's going to go there, and to clean it up, all right, I'm going to have t2 is equal to this right here. Okay, and let me bring that a little bit closer so you can see it. There you go. Hopefully that's a little bit better. I'll try and do that periodically so you can see things a little bit better. Okay. Alrighty then. Okay, so now what I do is I'm going to take this for T2 and I'm going to put it into the y direction equation. So instead of T2, I'm going to write this whole thing there. All right, so that's going to look like T1 cosine theta 1 cosine theta 2, like that. Okay. Times the sine of theta 2. All right. Plus T1 sine theta 1, all right, is equal to mg. All right. The mg again is known. We know the, let's say we know the mass. All right. So now I just have one variable. It looks kind of ugly, but don't let that deter you. These are just numbers. Cosine theta 1, let's say 1 is 30 degrees. Let's say 2 is 40 degrees. We don't really care. If you have a calculator, you should be able to solve that. So again, it looks kind of like this. All right, so hopefully you got a better view of that right there. Okay, now I'm just going to do some solving. The next thing I'm going to do is I'm going to factor out T1 out of both of those terms. Okay, so that's going to look like this. I'm going to put T1, big thing here, cosine theta 1, cosine theta 2, all right, sine theta 2, plus sine theta 1, all right, bracket it off, is equal to m and g. And this is not quite the same quality chalkboard as I have in the classroom. Sorry about that, but we're in a zombie apocalypse, so we make do. Okay? All right, now basically I kind of got T1. I have to do some calculator work, but I have it. So what I'm going to do is T1, you got to divide by this whole term, which I'm going to kind of skip that, and I'm just going to write the whole final thing. So I got that T1 is equal to mg divided by this whole big thing. Cosine theta 2. Okay. Sine theta 2 plus sine theta 1, and therefore at this point I can find what T1 is. Great, because once I have T1, now whatever number that is, then it's relatively simple. I would probably go to find what T2 is. I would probably go to the first equation in the x direction and solve for T2 once I know what T1 is. Let's say that T1 is, I don't know, just to use easy numbers, 10 newtons. I don't know what it is. We're just, I'm dealing without numbers here. But you kind of get it, all right? So let's say I know that, just, for those of you who like to deal with numbers. And once I do, now I'm going to go to the first equation, and I'm going to solve. I'm going to say T2 cosine theta 2 equals 0. I rewrote it. Now what I'm going to do is I'm going to basically write it again, or actually what this says is that T2 cosine theta 2 is equal to T1 cosine theta 1. So just to conserve board space. If two things add to 0, then the one thing is equal to the other thing. All right, so okay, I got that. And now, again, assuming now that I know what T1 is, because I did a bunch of calculator work here and I got it, I can easily solve for T2, and that would just look like this. So T2, okay, is equal to T1 cosine theta 1 divided by cosine theta 2. And again, if the angles are known, we pretty much have this. Okay, so T1, let's say, is 10. Let's say theta 1 is 30. Theta 2 is 40. Whatever. We got it. So and then we solve the problem. What are the two tensions that are holding up this mass? And that's a statics problem. Okay. All right. And again, let me get a little closer with this, so you can see it. And there you go. Okay, I think what I'm going to do is I'm going to end this video right here, because again, I'm still getting used to this. And I'm going to do a follow-up video on just a couple of variations of statics problems, okay, for you. And then I'll have you guys try and solve a few problems, okay? All right, guys.